Hello everyone. Am I live? Can you hear me? Just write in the chat box. Yes. Just write if so that I know that yes, I'm visible to you. Okay? Yes, hello. Okay. Great. I got the confirmation that is all right. Okay, so let me start. Let me begin now. Okay. So it's like this. Last time I covered the thing required for Olympiad thing. Like I told you that Olympiad have got different kind of books, and then maybe one point I made was that JE problems and Olympiad problems match sometime, and also that if you do well at JE Advanced, then of course there is some part of preparation is there which you will of course use in Olympiad also. So they are not exactly diametrically opposite, right? You have to have those kind of things. So that is all right. Okay, please come everyone. So I will start now another topic. So that is at the border of everything. You will again find that although this falls within JE syllabus, it has got applications in Olympiad also. Okay, and it's a strange method, right? So let me now share the screen and start with you. So what I have done, you might have known the title. The title says this. The title says that we have that quadratic in constant, right? That's itself a great title. Quadratic in constant. Now many people may question it. When you write ax squared plus bx plus c equal to 0, what are a, b and c? What are a, b and c? In high school we understand that a, b, c are just the coefficients and they are independent of x, right? Like that we tell. And then we write the famous formula minus b plus minus square root of b squared minus 4ac over 2a. That's fine. That can happen always. Okay. My point is that even if x is not variable, x may be a constant. Like how about this? Suppose somebody writes, pardon me for this one, I got a bad voice today. A times 3 squared plus b times 3 plus c is 0. Suppose somebody writing, then can I write 3 equal to negative b plus minus b squared minus 4ac over 2a? A is of course not 0. So what about this? Is this correct or not? Is this correct or not? The answer is that yes, it is of course correct. Although it looks very strange that how somebody can write a times 3 squared plus b, it's like equation in 3. But don't worry, justification is this, that when you write ax, it can be anything variable also. A may depend on x also. A may depend on x also, I repeat. Okay. See what exactly we are doing is this. The test is that what comes out of it. See, if you have got ax squared, so you have got ax squared plus bx plus c equal to 0. The question is how you arrive at this. How do you arrive at this? That answer is that we are doing something called completing the square. That's a time-honored technique that we are doing. The name of this name is completing the square. So we complete the square like this. What you do? We write a times, and then we write x squared plus b over ax plus c over a equal to 0. A is not 0, so I can take out, and that's why I divided also. So x squared plus b over ax, just some preliminaries for people who might be new. Now I can write this as x plus b over 2a whole squared, complete the square, plus c over a, and I have to subtract b squared over 4a square equal to 0. And I can write x plus b over 2a whole squared. I can bring it to this side, and I can write b squared minus 4ac over a squared. And this we interpret now in when things are all real and we want real roots, we say that okay, this number is, if this number is positive or at least 0, then we get something out of it, right? X, it is a value, something. So we have written something, x square is lambda, and then depending upon lambda we are interpreting that if lambda is 0, only one root. If lambda positive, two real roots. If lambda negative, still we can give the meaning, but it is geometry. It is just not geometry. It is actually complex numbers, right? So those things are really, really important. Okay. No, you are not late, Nityam. It's all right. Class started just now. Okay. Now, so this is what. So I never use the fact here that what B, A, and C are. Did I use the fact that what A, B, and C are? I did not use. I just told that, okay, if something is like this, I can always rewrite. Means somebody is telling you, see, I will go quite abstract. Let me turn the page. I can go quite abstract. I can say, that's what mathematics is. I can say that if you have got A times, let me add the slide rather. So if I say A times, and this is something squared, plus B times something, and C is 0, this something can be anything, right? It is up to you. It can be a stone, abstract level, it can be anything, provided you give some meaning to it in math, right? So it means you are saying whatever this box is, you can always write this box. No, this let's look at the previous thing. You can always write box plus B over 2A. So you can write box plus B over 2A, and this is whole squared, and this is actually B squared minus 4AC over 4A squared. That's what we got. And in fact, if box is a number or something else, then we say, oh, we get the roots. So we just we get them. So this can be. So first thing I want to tell you this, that don't think that A cannot be constant. X cannot be constant. X can be constant. So we say quadratic in T, in something, quadratic in something. We always use the phrase quadratic. It is a quadratic in, right? Your teacher tells you that speak like quadratic in what? In X, Y, to something. So today I will see some applications where the clever trick of making quadratic in constant, that itself is like hard to digest, no? That constant, quadratic in constant. So you see, I've written inverted comma like that. Okay, it is hard to digest, but see, this gives you the result when we will see shortly. So let me just first do this example: x to the 4 minus 2 root x cube. So let me copy it because the s is not there now. So x4 minus 2 root x squared. So x to the 4 minus, let me change the color, x to the 4 minus 2 root 2x squared, and then minus x plus 2 minus x plus 2 minus root 2 equal to 0. So we want to solve this. In fact, 2 minus root 2 is 0. Now let me check once more that yes, we are good. Problem is like copied correctly. Now the point is this, that now you cannot guess roots so easily because it is all irrational, right? You have something called rational root theorem, but that takes care of only rational roots. In dream, you cannot have some idea that how the roots are going to look like. They are pretty bad. They are pretty bad, in fact, and so you don't have anything to get on right now. What you do here, that think of this marvelous thing, that think of root 2 equal to a. So say root 2 is a. Okay, so far so good. Let me rewrite this and see what it looks like. X to the 4 minus, and then I'm writing 2ax squared minus x plus a squared minus a equal to 0. See, notice one more thing. I was very clever. 2 root 2 I did not write as root 2 cubed. No, that's what maths is. No, I wrote 2 root 2 is root 2 squared, right? Root 2 times 2 means a, 2 times a. Only one a I adjusted for a reason. Now see, it looks like it is a quadratic in a, right? It is 4th degree in x, but biquadratic in x, which we do not know anything, but it is quadratic in a. So let's see what good comes out of it. Some good may come out of it after all. So I will arrange this as a quadratic in a. So a squared minus 2x squared plus 1 times a. Keep track of my calculations. If something is not matching, please let me know. And then plus x to the 4 minus x equal to 0. So it's of course a quadratic in a now. With the roles are changed, reverse. The roles are changed now. Whatever was constant has become now the variable sort of thing, and whatever variable has become constant. So we have just changing the roles. So this is a squared a. Now let's see that if I apply quadratic formula, a equal to minus b and plus minus square root of, and I write b squared. So b squared minus 4ac, that is 4 times x to the 4 minus x, and over 2a. let's see that the inside radical something has come up. Is that something good or not good? So 2x squared plus 1 whole squared minus 4 x to the 4 minus x. This gives you 4 x to the 4 plus 4 x squared plus 1 minus 4 x to the 4 and minus 4x plus 4x. So this cancels and we are getting 4x squared plus 4x plus 1. That's something perfect square. That's like I did not think of, right? Nobody thought that this will come like this when we started. That okay, something it's come perfect square. So actually radical sign is removed now. So what happened that you are getting a equals 2x squared plus 1. Let's enjoy this, what we are getting, plus minus, and this whole thing goes out and gives 2x plus 1 over 2. In a way, what we have done, actually we are able to factorize this. What we could not do directly, we have done indirectly, thanks to make of the equation. No, equation was made like that. It is by design, by choice, right? If you tweak even one variable, suppose you make x to the 4 minus 6, all right. If you make 2x to the 4, it may not work, right? So once you have the idea, then you will try that, okay, maybe it's a constant quadratic, and then you will go get along. So here we will do like this. Now if you take plus sign, you will get a equal to 2x square plus 1 plus 2x plus 1 over 2, and that gives you x squared plus x plus 1. So good. And if you take negative sign, you will get a equals 2x squared plus 1 minus 2x minus 1 over 2. That gives you x squared minus x. So it has broken into two equations. So now I can solve it. So now I will write x squared. So let me add the page. I can write x squared plus x. I got x squared plus x plus 1 equal to a. And I also got x squared minus x equal to a. I also got x squared minus x equal to a. Now remember, a was root 2. Let's recall, a was root 2. Now is the time to put it back. So x squared plus x plus 1 minus root 2 equals 0. And this you get x squared minus x minus root 2 is 0. Roots are pretty bad if you think irrational numbers are, although I don't think so. So I will get x equal to negative 1 plus minus square root of 1 b squared minus 4 1 minus root 2 and over 2. So this will give me negative 1 plus minus, and this is 4 root 2 minus 3 over 2, and here you get x equals 1 plus minus square root of b squared minus 4ac and over 2. So I get 1 plus minus 4 root 2. I can write in any manner upon 2. So if I write this 4, I may write like this, that we got negative 1 plus square root of 4 root 2 minus 3 over 2. One number is this, other is negative 1 minus 4 root 2 minus 3 over 2. Then 1 plus square root of 4 root 2 plus 1 over 2, and 1 minus square root of 4 root 2 plus 1 and over 2. So you got 4 roots, and all 4 are real. See, all 4 are real. So that's the advantage, that all 4 became real. So is that clear? So let's review it, that what we got actually. Actually I got like this, that I started with, if this was given, see, you can start this only when you have got some experience at least. So you have got some motivation coming from some problems you have previously done, and you think that maybe it is a job for that. So we started with some motivation, and we said, okay, I know something called, after this chapter of course you know, there's something called quadratic in constant. That's itself like contradiction, right? You may think that what is it, quadratic in constant, say again, but you heard it right? And so I told you first of all that there is nothing unusual about quadratic in constant, and giving you this example that even if this is there, I can write 3. Nobody can stop me from writing this is correct. You can only question that what good it will do. That's a valid question, not that whether I can write it or not. I can of course write it. And I told you that follow the derivation, nothing it says that what x can be. X can be anything you like. I told it can be a stone, it can be anything you want, as long as you can give some meaning to it, right? So 3 is this one. and then I take this example and put root 2 equal to a. I was careful here, I just put 1 2, I did not do a cubed here. So this is one point you should remember. And then I made a quadratic in a, and then we got this one. Yeah, so somebody is really make a quadratic in Nityam Agarwal. Good, I like that. It's just like that you are making quadratic in whatever. The best math people say whatever, right? Whatever. And then you got a. So you got two equations for a. And then so what happened? What really happened? You are not able to factor it directly, but you factor it indirectly. Means that if I had written, let me show you here. Had I written, somebody had the x to the 4 minus 2x squared minus x plus a squared minus a equals. You have what you have done actually, you have factored this as x squared minus x minus a and x squared plus x plus 1 minus a, right? You can check that later, that you have factored. Directly you could not, indirectly you did, and so we got factored. One more thing I'll tell you now, that same thing I will do little differently without plus minus, the way we do factorization. Okay, so that will be a clever technique, and that is much shorter, and that gives you some inspiration also. Okay, so let me go to here. Okay, so now it was this, that a to the 4 x to the 4, or I will start from a only. It was a squared minus 2x squared plus 1a and plus x to the 4 minus x equal to. Let's check it was this, just to be sure that we don't solve the wrong equation. Yes, that is correct. Now see, if you have to factorize a squared minus 5a plus 6, what you do? For your first thing you do it as a high schooler, that you try to factorize this 6 as a product of two numbers which sum to this number, right? Sometimes it is difference. Now means you try to do something with the last term, that just factor them and see that whether you can make a 5 by them or not. Sign we can discuss later, right? For example, here you say that okay, 2 and 3 fit the bill, and so somebody can write a squared minus 2a minus 3a and plus 6, and then he's able to factorize by pairing anything that you want. Pair these two off or these two off. Similarly, in the same vein, in the same light, this, let's see, x to the 4 minus x. This will be quite inspirational and short. So here x to the 4 minus x I will factorize first. It's a good thing. X times x cubed minus 1, much shorter. X times, and x cubed minus 1 I'll write x minus 1, x squared plus x plus 1. So actually it is x squared minus x, and second factor is x squared plus x plus 1. Now you see, this guy in the middle is nothing but sum of these two. If you sum, you are done, right? So it means it is like a squared and minus, this is your something alpha plus beta a, and plus alpha beta is 0, right? If you think of this as your alpha and beta, then you are done, because exactly that they wrote. In fact, that's how the question must have been made, right? That somebody just put some numbers, but he gave you not a, he gave you in x, and so we thought that okay, how to factorize this. So this is easy. Once you realize that, you get okay, it is a minus alpha times a minus beta equal to 0, and so we get as we got at the last page. So that is the same thing is there. I hope that is clear. Okay, that thing makes sense. This was our first example, because it is new topic. It's our first example to make you understand that how it looks like working with a quadratic in constant. Let's move to the next example. Very interesting examples are there lined up. So let me check next. Okay, so next we have, I hope you have not missed anything. Yup, there is nothing in between. So first is the second example for us. See, this looks like again something different. Root 5 minus x is 5 minus x squared. Earlier equation had 4 roots. Now let's see what this gives you. For this, what I will do, again same thing, that I will write first of all 5. I become suspicious. I write 5 equal to a, just that it's a, so that I'm not considering of 5 anymore. So if I write like that, I will get here square root of a minus x is a minus x squared. And look, one more thing, if you want things to be defined, real numbers, solve the equation on R, so you will get x less than equal to 5, and from here I'll get x square less than equal to 5, because 5 minus x square must be non-negative. and so I get this one. So this will give you negative root 5 less than equal to x less than equal to root 5. Obviously, if this holds, this is honored, and so intersection is this only. So we look for roots in this. This is our domain, or this is our permissible values range of this one. That okay, let me look for these roots, that whether they lie. Now, so first of all, it is radical. Be careful about radical. You are squaring it, right? Squaring. So squaring may lead, not always, but squaring may lead to extraneous solutions, what is called bad roots, right? There are some genuine roots, there are some bad roots. But then you can't solve radical equation. The only way is through this one, through squaring. So square it now. So you will get a minus x is a minus x square whole squared. So from this I am getting, let me write this one. It's the pen thing. Okay, so this is whole gone, but I think it will come if I write this. Undo. Good. We are saved. Okay, so this is a minus x, and I get here a minus x square whole squared. So I get a minus x equals x to the 4 minus 2x squared, expand it, and plus a squared. Now you see again same thing is coming up, right? Momentum is building. So a squared, I write a squared, and if I plug here, I will get a squared and minus 2x squared plus 1a and plus x to the 4 plus x equal to 0, right? Something similar. Last time you got, if you remember, last time you got x to the 4 and then you got x to the 4 minus x. Let's check last time what we got. We got in the previous slide this one, x to the 4 and minus x. See, minus x. But don't worry, now plus has come, but that's not a problem. If you are observant, you can see that it is the same question. It is just that x replaced with negative x, previous slide, right? But it will have more roots. It will have less roots than the other one. Let's check that one. That is the interesting part here. So it is same thing now. So it's discriminant. If you find discriminant, that is 2x squared plus 1 whole squared minus 4 times x to the 4 plus x. So I got 4x to the 4 plus 4x squared plus 1 minus 4x to the 4 minus 4x. That these two cancel. I am getting 4x squared minus 4x plus 1. That becomes 2x. That becomes 2x minus 1 whole squared. That becomes 2x minus 1. That becomes 2x minus 1 whole squared. This is good. That time you got plus. So we can write a as minus b. So 2x squared plus 1 plus minus square root of d. Square root of d, that is here 2x minus 1 whole squared and whole divided by 2. So I get here a is 2x squared plus 1 plus 2x minus 1 plus minus and divide by 2. So if you take the plus sign, let me write on the next page. So I get a equals 2x squared plus 1 plus minus 2x minus 1 and over 2. And don't forget a was 5. So now if you take plus sign, you will get a equals 2x squared plus 1 plus 2x minus 1 over 2. That gives you x squared plus x. If you take negative sign, you get a is 2x squared plus 1 minus x plus 1 over 2, and so you get a as minus 2x. So you get this one minus 2x plus 1 over 2, and so you get x squared minus x plus 1. Now is the time to put back a equal to 5. So I get x squared plus x minus 5 is 0, and so if I solve it, I get negative 1 plus minus square root of 21 over 2, and here I'll get x squared minus x plus 1 is 5. So x squared minus x minus 4 is 0, and so I get x is 1 plus minus root of 17 over 2. It looks like we have got 4 roots now. Till it clear here? Everything is clear till here? Someone can write, some people can write yes, no, maybe. so I can deliver better, I can answer your queries. Is it all right? Everything is good? So I'll get this one. So I'll get here now -1. I am getting -1 plus root 21 over 2, and I'm getting -1 minus root 21 over 2, and here 1 plus root 17 over 2 and 1 minus root 17 over 2. Right? 1 minus root 17 over 2. 1 minus root 17. It has got some kind of intricacy now. There is some lag. Okay, Devraj, there is some lag. I told them last time that there is some lag, but apparently they said there was no lag, but I will take it up with them. Okay. Okay, I will of course do it. I'll of course do it. Don't worry. I will also share the PDF so that, and maybe I'll get the screen smaller because some of what I'm writing is not visible. Okay. Okay, so this is this 1 minus root 20. Here you have to learn one thing. Here you have to learn one more thing. That is very important. That thing is this. That thing is this. That now out of these 4 roots, which are the actual roots? See, we squared this, right? We squared. So we don't know that what are the good roots. Now this is only a necessary condition, not sufficient. This only tells you that all the roots. This only tells you that all the roots must honor it. They must honor it. They must lie in this range, right? That's all. But it does not tell that whatever honors it must be root. You understand that clearly? Means it is saying this is the domain, means that this is the set of values for which things are defined. It means any root that you get has to honor this. But it does not mean that whatever numbers lie in this interval all are going to be roots. No way. We don't know. We have to check only, right? Or we have to see about transformation, that what transformation we are creating. Now see, there is one way what we are doing. See, from here we have come from here to here, right? Here to here. We can, so in general we check, but here I can tell you a short method which is based on equivalence concept. Equivalence. See, if you just square, if you square here to here, no, from here you are coming from here to here, it's called a consequence. It's called a consequence. But under certain conditions it can be equivalence also. See, here both sides are non-negative. If you impose the condition that this right side must be non-negative, that is this one, then on this domain, remember, on this domain, on this set, say S, on the set S, on this set S, equation 1 and equation 2, they are equivalent. That's a good point. They are on this set, not on whole of this, right? Not on whole R. Whole R of course not there. So on this set they're equivalent. Why? Because you see that it is also non-negative, right? So it means there is no A equal to B. So it's like this, that A equal to B of course always implies A squared is B squared. This is a consequence. This 2 is a consequence of 1. But then they can be equivalent. They are equivalent if both sides are non-negative or both have same sign. I would say non-negative both are, then without loss of generality. So if both are non-negative, then 2 and 1 are equivalent. Means equivalent. It means if you find solutions of this one, then it is this one. They will satisfy this also. So on the set, this one, it is an important point. On the set negative root 5 to root 5, these two are equivalent, and so we need not check by actual plugging in the values. That will be too bad. I'll show you later. We did not check. We just check that which lies in this range. That's all. They have to be roots because they are because transformation is equivalent, right? So let me go next and show you. So negative root 5, you want to pick the numbers from negative root 5 less than equal to x less than equal to root of 5. This you want to put. Any doubt till here? Can someone tell that if there is some doubt or something? No? Okay. So now, see, now you want this kind of thing. Now you can approximate it, you can check. So what will happen is that negative 1, no? If any doubt is there, please let me know. Negative 1 plus root 21 over 2, that's 1. And other is 1 minus root 17 over 2. You see these numbers, these are the numbers that honor this bound. These two numbers. Negative 1, is it clear? Just check it. Negative 1 plus root 21 over 2 and 1 minus 220 over 2. Obviously this does not, or not this one. You see, this goes far beyond root 5, this one, and see the other is negative, it goes. So of course these two are there. If you test them, you will find yes, this and this, they really, this and this, these two work. And so these two lie in this interval, negative root 5 to root 5, this one. And I told you that once they lie in this interval, I need not check, because on this set, these two are, this is the point that bears repetition, that need to be told more and more, that emphasized more and more, that on this set, these two, 1 and 2, are equivalent. Means there is no loss of root, there is no gain of roots, they are equivalent. So they will have same set of solutions, possibly non-empty. That is fine in maths, right? Now, no solution is also a solution, right? Mathematicians are quite clever people, quite quirky people. So for them, no solution is also a selection, no solution is also a solution, and so on and so forth, right? Okay, so this is the point. And somebody could plug in also that would see, had you not observed this one, then you would have to plug the number. No, let me tell you how bad it is. But there is a way. Say if you do not know this, then maybe if you have to check that whether it is solution or not, what you have to do, this is square root of 5 minus x is 5 minus x squared. Just to make sure that question is correctly copied, just check. Yes. So it means that to show it is a number, it amounts to showing that verifying this identity, that 5 minus negative 1 plus root 21 over 2, and whether this equals 5 minus negative 1 plus root 21 over 2 whole squared. You can of course verify it, that's not a problem, but then that's not good job, right? Once we know they are identical transformation, we need not verify. We can quickly write this. So I hope this point is clear. This is the point. Yes, Nityam, that is correct. That we are saying that I just told you a times something squared plus b times something plus c. We are just making it a constant quadratic by assuming 3 as x. Correct, 3 is x. It is quadratic in x, right? And then you are really able to do it. Perfect. Okay. Okay, let me just go and tell you one more example. So this example is clear. We need not verify. 2 roots are there. Last time it was 4 roots, because see, last time 4 roots because it was biquadratic, right? And of course all four root came out to be real, and then no need to check, they are polynomials, they will satisfy. We did nothing. But here we squared it, and so we know they are not equivalent, but we know they are equivalent on this set only, and so we found out that only 2 roots are there. Okay, let's go to another example which comes often. Yeah, we already have the value of s with x as 3, correct. So we are saying 3 is this. Means, see, Nityam, what the good thing was that we really factored this in a clever way. We factored it. Ultimately what we did, that we, by this method, by changing the role of constant and variable, means by considering or by making it a quadratic in A, we are able to factorize this one indirectly, what we could not achieve directly. That's the power. So what we could not do directly, we are able to do indirectly, right? That's the kind of amazing thing, that quadratic in A. And that, so first time when I learned it, it was quite eye-opener for me. It was quite amazing that, okay, this is aha solution, that this is just something out of the world, right? And the moment anybody who loves math, so it will stay with them for a long time. No, that okay, they never thought like this, that role could be reversed and we could get something. And the point is that we could get something useful out of it, very useful out of it, that we got. Okay, now let me, yeah, but infinity. Okay, Devraj, your question is like that, but that is not very good. Why? Because see, infinity always comes with a question of convergence, right? So that's my next question. It's a very important point, Devraj, that you have raised, that can I iterate? You are iterating and you are getting, but then the thing is this, that how do you know you are permitted to do it, right? For that you need to prove that yes, they converge. So that's the really good point. Okay, so that you cannot apply in subjective. Objective, all right, but subjective, avoid that argument. Okay, next question will show it. Next question will show it. Now see this one. It's exactly the thing that you said, the many viewers are saying, and then same thing that I'm telling. Let's see. Now this question, see, they're writing given that it exists, given that, why didn't they write? What was the need to write? Correct? In high school algebra, in class 8 or 9, you did your first example of this sort, root 2 plus root 2 plus root anything, this kind of thing. Find this value x. You never worried about that, whether this exists or not, because it was given that, okay, assume that it does, because somebody knows that it does, and then you are saying that, okay, if it does, then you are saying that if it does, then x is, I can write x is root 2, and plus from here it is same chain, this kind of thing. And so we'll say that it is still x2 and plus this one x, right? So I will write root 2 and plus x, and then again I can solve, and I know it is non-negative, in fact positive, non-negative also is correct word, non-negative, and so I can pick the value. So that is what we did in high school, in class 8, early childhood, right? But then things become tricky now. Things become tricky. Okay. Okay, Nityam, I'll try. Okay. So now this is this one, that root 2. So this will become that root 2 plus x, right? This is now. Okay. Now, so maybe next time I will try to do. Okay. In the middle, changing will not be good. Okay. Now see, x is root 2 plus x. So here we are spared. Nobody told you to verify for this one, that, okay, do verify that they exist, it has got a meaning or not, right? See, in maths these things are important. Unless something is a meaning, you may run into trouble. One example comes to my mind is this, a very pertinent example, because you have asked that, suppose x is 2 plus 4 plus 8 plus 16 all the way to infinity, right? It came in Roorkee entrance long back. They said that explain this. So what they said, what is wrong in the reasoning? X is this. They multiplied by 2, as we do, 2x. They wrote 4, 8, 16 all the way. Then subtract it. Negative x is 2. It is negative x. Check negative x. So x becomes negative 2. How come? Right? Or x is known to be a sum of positive numbers, and we're getting negative 2. Is not this something need to be explained, that how negative 2 is coming? The same thing if you do, or probably you know the reason, the same thing if you do with this one, that x equal to 1 plus 1 by 2, 1 by 4, 1 by 8, you don't face any problem. The same thing if you apply here, you don't face any problem, because things work fine. You are writing half x, and you write everything displaced by this one. So writing half. So writing half plus 1 by 4 plus 1 by 8 and so on, and you subtract again, you get x over 2 is 1, and so you claim x is 2. That indeed correct, but here it is not correct, right? Correct. So what happened? What happened is this one, that this time, yeah, what just Roorkee was really good. So they said to explain. Now the reason is this. Reason is following. First of all, this sum has no meaning. This sum has no meaning. It is infinite, right? It does not converge in the technical language. So we say that 2, 4 plus 8 plus 16 has no meaning. But you have taken it to be x, and you are assuming it to be a finite number. Why? Because see, x minus 2x, if you write negative x, you are saying that x is finite, because nobody can write infinity minus 2 infinity is negative infinity. That kind of thing does not work, right? Infinity plus infinity is all right, but infinity minus infinity is not 0, right? So it means you are writing this, so you are treating this whole thing as a finite thing, x, because you are subtracting, and so that's the reason why you are getting a wrong answer, or that's the reason why you can not explain. Is that clear now? Is that clear to everyone? Is there some lag, or there is no lag? Now there is no lag, correct? Or there is lag? Yes. Okay. So let me tell you again. So what I told here is that here we took 2 plus 4. We committed the mistake of 2 plus 4 plus 8 plus 16, which has no meaning. We wrote this as x, assuming x to be finite, just like this one, finite, and then we did some operation. So we did operation of subtraction on infinity, which does not obviously hold. This holds only for x element of R, does not hold for all, and you did it. So obviously whatever you get can't be trusted, right? So that's what you get wrong. Here you got correctly. So same scenario. So math people say that this is divergent series. This diverges, means it has no meaning. Diverges, we have no meaning. Infinity, you can't equal to finite. And this converges. This converges. That's a whole new issue, convergence, divergence, which is not in JEE syllabus, but it is good. You can learn somewhere, sometime. Okay. And see, that's why in good books or in good exams they will write find the value if it exists, because the convergence issue is not there in your syllabus till class 11 or 12. It is done in undergrad courses, right? In course of analysis or calculus when you go to IIT or some other thing. So right now it is not there here, right? Siddharth, yes, there is a range of values. You can show that it will converge for all. It will converge for all. You can say, you can show that it can converge for all. It can converge for this will converge. Like this is, there is a test you can apply. We can say it converges. We can write xn plus 1 recurrence. We can do it. But then that's why I have given you to a spare this. I have given you it exists, right? Because convergence issue is out of question for us, and so I get you okay exist. Otherwise question could be technically wrong. Okay. That is separate. Minus 1 by 12 is separate story. That is not the natural. That is some different base, right? So okay, we'll talk about it later. That thing is not here. So now this will let me find this one. So we are given it exists. That's the whole thing we do. Now if you write, so this has got a good answer, really good answer. This one, these two have got good answers, like natural numbers, positive integers, and so one I will do A. So let me do A. So you have got, I can write like this. Let me add a page. So let me write x. X is square root of 7. Root of 7. 7. First it's 7. It is 7 plus the square root of 7 minus square root of 7, square root of 7, and all those numbers. Just check that it is same thing. Plus, minus, plus, like that, right? So it is plus, minus, plus, like that goes off. So what you write here, and to infinity it is going off. So you are writing x equals, in solution you are writing x equals square root of 7 plus root of 7, and this whole thing, again you are replacing with x. So you are writing 7 minus x, because it goes to infinity, right? And we have shown that this has got a meaning. We can we can subtract 2. No, you cannot subtract. We can't subtract. You cannot subtract. We cannot subtract divergent series, right? See, this is this one. I said that the whole point was this. Why this came? Because we just applied it, considering that we are dealing with finite numbers, right? When we wrote x minus 2x is negative x, at the back of our mind we had this, that okay, these numbers are real. These numbers are real numbers x, but not real. It has no meaning only. It does not converge, right? So your question makes sense, Nitin Agarwal. So it is not. So I said that this cannot happen. Actually, Rudki asked that explain the fallacy in this reasoning. Explain the fallacy. So explain the fallacy means the wrong thing. Fallacy in this reasoning. No, reasoning looks okay. You might have seen many proofs in which they prove minus 1 equal to 1, right? You might have seen those tricks, those proofs. They claim minus 1 is 1, and there the mistake was some other thing. Nityam, the Ramanujam thing I will tell you later. That is a different series. So that is not part of our today's lecture. So that I will make a separate video on this and I will post it. Okay, that I can do. Okay, that's a series. Okay, now this one. Now this one. So I write x, and then I write now x squared is 7 plus square root of 7 minus x. Again I can write x squared minus 7 whole squared is 7 minus x. Now 7, again you put 7 as a, as you did. Now you understand that this is same thing, no? You understand that this is actually pretty same thing, nothing different. And so what we are doing here is that now we are doing like this, that one more thing, let me take care of, or let me do it first. So x squared minus a whole squared is a minus x, a squared. So x to the 4 minus 2x squared plus a squared equals a minus x. Arrange the quadratic in a. So a squared minus, bring everything to this side, 2x squared plus 1a, and plus x to the 4 plus x equal to 0. If you remember, this is, we got this one some time back, right? we got this last time. So let us take advantage of that, and let's write directly the solution from here. So a, we got positive, negative, two things we got a. So this is plus x. So let's check that in case of plus x what we got. So in case of plus x, this one, it was this plus x. We got this one. We got x squared plus x and x squared minus x plus 1. We got like this. So we got x squared plus x, and we got x squared minus x plus 1. This we got. If this we got, then what we can do is that now is the time to put values of 7. So I'll write x squared plus x equal to 7, and I'll also write x squared minus x plus 1 equal to 7. So I get x squared minus x minus 6 is 0. That nicely factorizes. It factors. It turns out to be x minus 3, x plus 2 equal to 0. And so x cannot be negative. So x has to be 3. X is not negative because it is c root. So x has to be 3 here. Let's check this one. It is x squared plus x minus 7 is 0. This indeed give you real roots. Let's write here. X squared plus x minus 7 is 0. That gives you negative 1 plus minus root of b squared minus 4ac. So that is 29 over 2. This is, so you are getting negative 1 plus this over 2 and negative 1 minus root 29 over 2. But see, you know this has unique value. This has got, this is some number, right? This is some expression like 2 plus 3 plus 5, right? So this has got unique value. This has got, this cannot have two values, right? Unique. This has got unique value. Everything is defined. And so you got just, so we should get just 1, right? We should get just 1. So just 1 means what? Like just 1 means that now already negative is not there. Why? Because see, from now comes the domain part. Now see here, notice this equation, this one. Already x positive is known. That's the very crude bound that x is non-negative. From here, we know that in fact x is root of 7 plus something non-negative. And so x greater than or equal to root of 7. That is one thing we know. And we also know that for root 7 is to be defined, it is very crucial, x less than or equal to 7. And so we know in totality that root of 7 less than or equal to x less than or equal to 7. Is that clear? We got a bound for this one. We got a bound for this. We got a bound for this, right? So we got a bound for this. That is good enough, because now I can say that on this interval, no, it is this one. On this one, see x squared minus 7, correct? Root minus x. So now let's check that what fits the bill. So these already are out. These negative numbers are out. This was out. 3 of course satisfies. Let's check for this one. Negative 1 plus root 29 over 2. That whether this falls here or not. And then if it falls, whether it is a root or not, right? Both should be there. Yes or no? Do you agree that both should be there? Okay. So negative 1 plus root 29 over 2. We have to test that whether this is less than 7 or greater than 7. Right? So what is your guess? That this is less than 7 or greater than 7? And if this is there, then what should we do? Should we take that or should not take that? Any idea? Anything? So it should be root or it should not be root? It should be or should not be? That's the question. No or yes? We know it has got one value. So already we got one value, 3. We can test it also. What about this? We want to test this further, or we don't want to test this? Or we want to reject them? It is less than 7. And it is more than root 7 or not? Is it more than root 7? Less than root 7? Yes? Yeah, correct. It is less than. So in fact, you will find that this is less than root 7. Otherwise, it would have been a root. Less than root 7. Why? We can check like this. Like my method is this. Although we can put values also, but I would say this way, that test like this. Let me go to the next page. Test like this. You want to test that whether minus 1. We want to test whether minus 1 plus root 29 over 2, this one, is less than root 7, correct or not. This you want to test. Somebody may approximate also. Okay, but I will write this one. I will write this to indicate that it is still in the testing. We do not know if it is true or not. We'll write like this. So what I do, my method is this. The good method is this, that negative 1 plus root 29, I will write less than 2 root 7. That is, I'm writing that is. We are proving this means that is. Don't approximate also you can work, right? But I think this is better sometime. So, or you can learn as another method also. So -1 plus root 29, this one. Now square it, because both sides are non-negative. That is, you are testing this. That is 1 minus 2 root 29 plus 29 less than 28, and so you bring it this side. So you will get 1 minus 2 root 29 plus 29 minus 1, so plus 1 less than 0. Now you are good, because 2 less than 2 root 29, which is true. This is much lesser, so it is true, right? It is true. It means that you have proved that yes, this is indeed less than this, and so this number is also rejected because this does not lie in this range. And I told you already concept of equivalence here, which is valid here, that this one, when I wrote this one, I can rewrite here and show you that you are actually squaring x squared minus 7 is root of 7 minus x. So you square it, and then they are equivalent on the set x squared greater than equal to 7, right? And x is of course less than equal to 7. So this gives you x greater than equal to root 7, or x less than equal to minus root 7. So you will find that they are equivalent on the intersection of these two sets, and so you will find that only one root occurs, 3. As we expected, it has only one value, right? So it is 3. I chose this number because 3 is a good value, right? And you test here now, it is very good. Now 7 minus 3, 4, right? If you check it here, it is good looking. That x is root of 7 plus root of 7 minus x equal to 3. Yes, indeed. So this is 3 root of 7 plus root of 7 minus 3. So things just merge in a good manner. 7 plus 2, and then we again get 3. So we have verified, but there is no need to verify. Just I showed you the clever thing. I hope that makes sense. That is clear. Okay, is that all right, guys? Perfect. Similarly, you can solve for b part also. B part, like b part was like, let me check for you that what other thing was. Okay, so now this is also, you can write this. This is good enough. This you can do this one, right? Correct? Okay, all right. There is some lag. No lag. Okay. Manav is saying lag. VB KRB is saying no lag. Okay. Now, so this also you can do similarly. This, the easy one, you can do quickly. This also will come very quickly. It will come. Okay. Let's go to the next one. Now, what about this? Is a parameter. A is a parameter. This one. This is a question which you have to again answer, because this is now really good one. So this, I will just get you started. That actually a positive given. So first of all, you will have the bounds. So you will write here that you will square it. You will write x squared is a minus root of a plus x, and you know that for x to be a root, for this to be a root, you know that x plus a has to be greater than equal to 0. So it's equal to negative a, and you know here that here, this one, that it must be defined. So x is root a minus something, so x less than equal to root of a. See, this time x is something, this one, and but you see here x, it is root of something, so x must be first positive, right? X must be positive, so it means you get 0 less than equal to x less than equal to a square root of a. That is the bound you get for x. Then everything is defined. So this is what you are getting, and in fact this also must be 0. So we can write a minus root of a plus x greater than equal to 0, which will be taken care of, right? So now you check that this is there. So we will do the same thing. We write like this: first squaring done, first squaring equivalent, because both are non-negative. Second squaring I have to do right this way, that root a plus x is a minus x square. But this is not a problem. We are given this one, means a greater than equal to x square. This one less than equal to a. This will follow positive, and so they are equivalent. So I can again square and write this is a minus x squared whole squared. And if you do this, then you will get exactly the same thing. X to the 4 minus 2x squared plus a squared is a plus x. And so you are getting here x to the 4, a squared again, a squared minus 2x squared plus 1 times a, and then plus x to the 4 minus x equal to 0. So you got the same thing. So you will get 2 values of x or 4 values, and again you have to, yeah, this is the same thing, but Siddhant, it requires a little bit more careful thing, because a is not given, a positive, so you have to make cases, right? And then this is good thing for analysis, that you have to analyze the questions, that how it, so I chose it. Especially students have difficulty in problem with parameter, because they require really lot of care. I mean, you cannot be so careless as you are in case of 5 was okay, easy, okay, that kind of thing. So you can, I think you can complete it from now. You can, from here you can complete it, that you will get something, and then you have to honor this bound and you will get answers. So you'll get that, okay, this is the answer for this. See, a positive given, they have given positive also. Okay, as a final example, I am taking something that is not trivial. It is the real example. See, now this here comes the power of Olympiad maths. That now, see, now what will happen? Now this is, see, now you cannot say that the a cube x4. So how do you do that? Now it is cube is there, right? Cube is there. That thing is not correct. You cannot take like that a is x squared. About this question, how do you attempt it? Because it is a quadratic in, it is not a quadratic in x, of course, it is 4 degree, and not a quadratic in a also. It looks like that we are doomed, like we don't have any more thing to do. So how do we take care of that? Any suggestion that how do you take care of that? This is going to be the highlight of today's session, that this is how do you reduce it. That's what Olympiad problems do. They take a genuine idea which is known to many people, but then they tweak it a little and make it, you know that you have got the idea, but now you have to make the idea work. No, think of, no, not completely. Think of constant only, quadratic in parameter. But what is the parameter? A is not there. A is not there, of course, right? So it's not same. Some of you can try that. It is not exactly the perfect square thing. No, not really. I mean, see, this is what I mean, that this is same idea, but this is now heavily disguised. I give you some time to think it over. Now this is heavily disguised. This is not as easy. Is that clear? It is not as easy. So you just have to think of that how you can do using the concept taught right now, that think of some parameter. It may not be a, something different, some parameter in which you can play the same thing again. Maybe you can play the same thing and then we are saved. Okay. So it is a you have factored it, but how it is a quadratic in something? Is it a quadratic in something? Yeah, it's an innumerable problem, of course. So it is quadratic in what? Yes. Some people have answered that, so it Siddhartha has answered, but you might have factored. But I am saying that how do you reduce the quadratic in this one? It is not a no, it has not come in INMO. It has not come. It is an innumerable problem. It is not coming in INMO. Say, it is like this. Although people might have done by factoring, that's all right. That's great about it. Okay. The way I would do is this. The way I would do is I would write here ax multiply with a. That's your thing. A to the 4 is to the 4 plus 2a cubed x squared plus ax plus a squared plus a equal to 0. Assume a is not 0. If a is 0, then of course it cannot happen, right? X is minus 1. Now think of ax to the 4 plus 2 times a times ax squared plus ax plus a squared plus a. So your ax is now, ax is something t. So you get here t to the 4 plus 2at squared plus t plus a squared, perfect solution, plus a squared plus a equal to 0, right? And now it is a quadratic. Now it is a quadratic, right? Now it is quadratic. A squared, you are back to the same track. A squared plus 2t squared plus 1 times a, and plus t to the 4 plus t is 0. And that's what we did. It is what is known as maths. That simply it is superb. That what you have done, is that somebody just make you a cubed. Somebody just put a spoke in your wheels. They said that no, you have run AB, they'll make a cubed. And by slightly tweaking, you have got it ax. So I hope that is clear. This is a good problem, because anyway so Olympiad problems are either say you can say that they are heavily disguised or sometimes thinly veiled, and so you can have this kind of thing, right? So this kind of thing will be there. Is it clear? It is heavily disguised, but still I think if you just know it, then you can quickly do it. I hope that's clear. Anyone having any doubt? I wrote ax equals t. I wrote ax equals t. Ax equals t I wrote, and then I got all the thing. Okay, all right, that's all right. Perfect. So what I will do, that I will keep like bringing these kind of videos, and you can write in the chat box if you need something. This is going to be last problem, so I'll wrap up now. You can write in the comment box that what really you want to be done by me, so that based on your feedback I can come up with different topics. Like somebody says that okay, this topic, so think of like maybe that majority of people, like 10 people, 20 people, if they write that okay, this is the kind of thing we want, then last step I'm telling you, yes Nitam, I'll just tell you, but then you can of course write that okay, this is what in chat box, do write, do comment, and do write that okay, this thing you would like to be taught, or this thing is troubling you, so that an academy can come up with the good videos, and then I can also contribute that okay, this is the kind of thing that students really want or they feel not comfortable at, and so I can yes, so give the topic subtopic number, that will be better. If you write only number theory, that is very big topic, number theory or algebra, so maybe a small topic will be all right, a small subtopic, so that we can have functional use. Okay, we can have. So I will tell the last step again. So what I did here, that this seems to be a cubic in A, right? Cubic in A or something. So, but I know only quadratic. So I multiplied by I wrote it to 4x to the 4 plus this thing, 2a cubed. So x to the 4 plus this. So now put ax equal to t. So it is to the 4 plus 2at square plus this plus this. It is quadratic in A now. Okay, Nitin, I'll try. It is quadratic in A now, and then of course from here it is good elder story. You can write, and we can go, and we don't know real number. We will of course get roots, and we have to find how many are real or not. So that is what it does it. I hope this is clear. Okay, guys. Okay, so now is the time to wrap up. It was nice interacting with you all. So stay blessed, stay safe, and we'll keep meeting. I will keep posting updates about the topic or subtopic I will be taking up. And some of you can also write that you can be a little specific that what you really want, and then of course I can come up with more matters. Okay, nice everyone. I'm signing off now. Lots of love, lots of hugs, and then bye. Take care.